In the arena of modern mechanized combat, a staggering discrepancy exists between raw firepower and actual market survival. The China QN-506 Terminator, a vehicle unveiled at the Zhuhai Air Show with the reputation of a new king of land warfare, remains completely exposed to a devastating commercial failure as of June 2026. Equipped with 24 missile tubes, an automatic cannon, and an integrated reconnaissance drone, this platform was designed by Wuhan Guide Infrared to turn obsolete armor into a futuristic fortress. Yet, leading global defense analysts argue that despite its terrifying appearance on paper, it has secured zero international export orders and zero domestic military contracts. How can a multi-role combat system costing only a fraction of a Western infantry fighting vehicle become entirely useless on the global market? The tactical salvation promised by this arsenal on wheels has turned into a strategic dead end, leaving military planners to realize that a fundamental design flaw is hiding directly beneath its heavily armed exterior. The stakes are critical for countries attempting to modernize their older fleets, as opting for this chassis modifications might leave their crews completely defenseless against modern electronic warfare and cheap, loitering munitions. This brings us to a critical paradox in defense acquisition, where cramming 21st century digital technology onto a platform from the previous millennium creates more vulnerabilities than advantages. Are we witnessing the permanent extinction of the dedicated tank support vehicle concept after its poor showing in recent European conflicts? Before we go on, if you want to stay ahead of the latest deep dives into global military technology, smash that subscribe button right now. Do you think firepower matters more than mobility in modern combat? Drop your thoughts in the comments below and tell me where you are watching from. To understand this catastrophic failure, we must strip away the marketing hype and examine the harsh physical realities of the vehicle. The primary engineering flaw of the QN-506 stems from a radical imbalance between its modern turret and an ancient chassis. Wuhan Guide Infrared attempted to cut costs by mounting a highly sophisticated 8-metric-ton digital turret onto the chassis of a Type 59 main battle tank, a platform originally designed in the year 1950. While the weapons array is futuristic, the vehicle retains its original 12V150L diesel engine, which produces only 520 horsepower. This forces a 32-metric-ton combat vehicle to operate with a dismal power-to-weight ratio of just 16, 2 horsepower per metric ton. During field trials observed by international delegations, the vehicle struggled to maintain a cross-country speed of 30 kilometers per hour, making it far too slow to keep pace with modern mechanized formations like the Type 99A main battle tank. Beyond the engine, the logistics of this design create a severe tactical liability. Independent defense analysts, observing modern urban combat trends, note that heavy turret overloads place immense mechanical strain on the obsolete torsion bar suspension system. This engineering oversight triples the probability of critical track failures during rapid maneuvering in confined spaces. Furthermore, the 3-man crew consisting of a commander, a gunner, and a driver faces an overwhelming cognitive load. In a fast-paced engagement, a single gunner must simultaneously operate a 30mm automatic cannon, track target paths for the QN-201 laser-guided rockets, and interpret complex thermal telemetry from the tethered drone. Simulators deployed in the year 2025 demonstrated that this cognitive bottleneck caused crews to miss critical threats approaching from the flanks 64% of the time, proving that this platform is structurally and operationally unviable for contemporary warfare. The battlefield realities of recent conflicts have effectively shattered the tactical foundation of the QN-506. Combat data gathered between the years 2024 and 2026 demonstrates that heavily armed vehicles without hard-kill active protection systems are incredibly vulnerable to cheap drone attacks. On the modern battlefield, a single first-person view drone costing $500 can easily compromise a platform worth $2 million. Because the QN-506 features exposed missile pods on its exterior, a top-attack drone strike triggering a secondary ammunition explosion would immediately render the expensive optical sensors and the entire turret completely useless. This vulnerability explains why the Chinese military has completely bypassed this concept in favor of their intelligentized warfare doctrine. Military planners have realized that instead of allocating $2 million to upgrade an obsolete tracked chassis, a country can achieve superior tactical results by investing in mobile wheeled platforms. For the exact same cost, a defense force can procure two ZBL-088x8 wheeled armored vehicles equipped with high-energy microwave electronic warfare modules. These modern systems can fry the internal circuitry of approaching drones from a distance of 1.5 kilometers, while traveling at speeds exceeding 100 kilometers per hour. Consequently, international defense procurement reports from the first half of the year 2026 indicate a 45% decline in global spending on modified heavy tracked vehicles. Military forces are rapidly shifting their budgets toward highly maneuverable, network-centric solutions like the Dongfeng Mengshi M-Hero 917 multi-purpose vehicle, which delivers superior battlefield survival rates through speed and integrated electronic jamming, rather than relying on an excessive accumulation of uncoordinated mechanical firepower. The commercial isolation of the QN-506 highlights a profound dilemma that shapes modern defense procurement strategy. Global defense ministries face a definitive choice between two clashing military philosophies. On one side is the traditional approach of modifying obsolete legacy hardware with excessive mechanical firepower to minimize costs. On the other side is the contemporary doctrine prioritizing electronic integration, high mobility, and dedicated counter-drone technologies. The total absence of export orders for this vehicle in June 2026 demonstrates that cramming futuristic weaponry onto an outdated chassis from the previous millennium creates a highly compromised system that satisfies neither doctrine. The strategic lesson here is clear. In 21st century warfare, a platform that attempts to perform every single tactical function often ends up performing none of them effectively. Wuhan Guide Infrared built an impressive technological showcase, but they created a tactical mismatch for the reality of modern combat. True military power no longer belongs to the vehicle carrying the most missiles, but to the network capable of distributing sensor data and executing electronic jamming in real time. As defense budgets globally adapt to the lessons of recent drone-saturated conflicts, the era of heavy tank support vehicles built on antiquated hulls appears to be at a permanent end. This leaves defense planners with a final critical question to debate as they look toward future force designs. In an era where a 500 United States dollar drone can neutralize a multi-million-dollar armored vehicle, should military forces continue investing in expensive heavy combat platforms? Or should they shift completely toward decentralized drone swarms and high-speed electronic warfare vehicles? Share your perspective in the comments below. Leave a like if you found this analysis insightful, and make sure to subscribe to the channel for more comprehensive military technology updates.